Hello, 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 ladies and gentlemen, and welcome back. We are looking at question 21 in this video on our 2018 Cayley math contest. So what have we got in store for us? In the diagram, each of P, Q, R, S, T, U, and V, a big picture over here, is to be replaced with 1, 2, or 3. Okay, so we'll probably have some duplicates, but what are our conditions? So that P, Q, and R are all different. So one of them's 1, one of them's 2, one of them's 3, although not necessarily those that I've drawn in there. Q, S, and T are all different. So if Q is 2, then S and T have to be 1 and 3 or 3 and 1. And finally, R, U, and V are all different. So basically, if you share a triangle, or even if you share a line, you have to be different values. That's what I think the picture is meant to sort of symbolize and help us organize our thoughts that way. What is the maximum possible value of S, T, U, and V? So these four numbers right here. Okay. So we might think, well, how can I make the largest possible value? And I'll just copy the picture here. So P, Q, R, S, T, U, V. Okay, so we care about S, T, U, and V. Well, if the numbers are only to be 1, 2, and 3, you would think, well, just make them all 3, right? That would get me the largest possible value no matter what, and that would be 12. Now, if you look carefully, 12 isn't even a possibility. Why is that? Well, because we can't have S and T both be 3. They have to be different numbers. Just like we can't have U and V both be the same number, so they can't be 3 as well. So that sort of gets us to revise the idea and say, okay, well, the biggest we could get, knowing that these pairs have to be different, would be a 3 and a 2 and a 3 and a 2. That's as big as possible, right? And that would give us an answer of 10, and that is one of the potential answers they have listed. But we have to be careful. Just because we think we can write 3, 2, 3, 2, we haven't actually shown that you can sort of complete and get the other 3 numbers satisfied, because look what happens. And I'll use the pink, I guess, because the yellow isn't the easiest to read. But if we've got 3 and 2 here, and Q has to be different than S and T, this is forced to be a 1, just like R is forced to be 1, but then we've got Q and R are the same value. So that won't do. That's not allowed. So we're trying to find the biggest value. We're basically saying, what could S, T, U, and V be? And we're having to slowly revise and say, no, you can't have that. You got to at least have this. You got to have at least 3s and 2s. You can't just have all 3s. Well, now we can't even just have 3s and 2s because you'll get 2 1s here. So what could we do? Well, we could make one of these ones a 2. Okay. Now, why would we make it a 2 and not a 3? Because if I make it a 3 up here, then I'm not allowed to have a 3 here, and it has to be a 1. So that's getting rid of sort of 2. That would make our maximum 8. But if we just say, well, it's a 2, we can still have our 3 here. We have to drop this 2 down to a 1. So we only lose 1 value, and we're down to 9. And if we check, yeah, 3, 2, 1, 3, 2, 3, and 1 will work out. This does satisfy the conditions, and 3, 1, 3, and 2 make a total of 9. So we can't have 12. We bumped that down to 10. 10 looked good until we realized, well, that means you're going to have 1s here. So that's not allowed, and so we just go 1 lower with 9, and so 9 should be our answer, and that will be B, and we will bubble that in. And we're all ready for our next question. That'll be question number 22. I will see you for that in the next video.